In this video, we'll be covering some polynomial basics, including how to determine whether a function is in fact a polynomial, how to write a polynomial function into standard form, and how to determine the degree, type, and leading coefficient of a polynomial function. So polynomials are created by using something called a monomial. So in order to understand a polynomial, we have to understand the definition of monomial. And a monomial is a number, a variable, which means some letters, or the product, which remember product means multiplication, of numbers and variables. So what we have down below are a number of examples, and what we're going to do is we're going to go through and we're going to decide which ones are monomials and which ones are not, and discuss why things may not be what's called a monomial. So if we look at the first one, we see 10, and 10 is a number. So it fits the definition of a monomial, because a monomial can just be a number. So this 10 is in fact a monomial. Now this next one contains a number and a variable, and it contains a product here as these are smushed together, but the problem is that there's this extra little piece in here. We have the square root of x, which is producing a root of a variable, which as a result makes this not a monomial. So if you see a variable in a root, you can automatically conclude that what's in front of you is not a monomial. Now next we see a number of negative 1.8, and then we see m to the power of 5. And at first that might seem like it's not a monomial, but remember that m to the power of 5 is really m times m times m times m times m. Because of that, this is a product or a multiplication of a number and letters. So this is in fact a monomial. Then if we look at the next one, we see that we have a number and a variable, but because we see this division sign here and we're dividing that number and that variable, we can automatically assume that this is not a monomial. So this division here is the problem. Then if we look at this next one, we see that we have the number 1/2. So now note, even though that contains a fraction in there in division, it's actually the number 1/2, which is okay. And then from here we have times a times b to produce that b squared. So this is what we really have, which is a number times some variables, or the product of a number and variables. And as a result, this one here is also a monomial. Now this next set here is addition, and because a monomial requires a product, this is not a monomial. Then over at the second to last one here, we see x to the power of negative 1, and if we think back on what we learned in algebra, we know that this is really 1 over x to the power of 1. Now when we make that exponent positive, we see that this is really division, another case of division, so this is not a monomial. And then this last one here, while it contains a number and a variable, because this variable is in the exponent, this is a problem. This actually results in a different type of function, and because that variable is in the exponent, this is not a monomial. So make note here of the things that produce items that are not a monomial. You can't have a variable and a root. You can't have division between a number and a variable. There's no addition, and you have no variables in your exponents. Now, the next thing we need to talk about when dealing with a monomial is the degree of a monomial. And the degree of the monomial is the sum of all of the exponents of the variables in the monomial. So each of these down below represents a monomial, and we're going to find the degree of each. Now, this little note right here actually deals with number 1 here, and we see that we don't have any variables in that first monomial example. And when there's no variables, so notice that it's only a constant number, this has a degree of 0. So it's got a 0th degree. Now if we look at the second example there, what I notice is that I have one variable with an exponent of 5. So this would be a fifth degree. This next one here, while the a doesn't appear to have an exponent, it actually has an implied exponent of 1. So I take those variable exponents and I add them together. And this one has a degree of the third degree. Now this next example down here, I see that this has an exponent of 1 implied. And because it only has one variable, I just take the degree of that one variable, which is going to be a first degree monomial. This next one has 3 different variables, so I add together their exponents. 2 plus 5 plus 3. Well, 2 plus 5 is 7, plus 3 is 10, so I have a 10th degree. And then from here, this next one has a couple of implied exponents of 1, so I have 1 plus 1 plus 2, which gives me a 4th degree monomial. So now that we understand what a monomial is, let's dive in and look at the term polynomial. So a polynomial is simply a monomial, or it's a sum of monomials. So it's one of those two things. A polynomial can be just a monomial, or poly means many, it can be a sum of monomials or many monomials added together. So what we're going to do here is we're going to go through and we're going to look at each of these terms in a polynomial. So each of these monomial options is called a term. And what we're going to do is we're going to decide A, are all of these terms monomials that are added together, and B, are we adding together a bunch of monomials? So if I look at this first example here, I first need to check if I have a sum of monomials. So I can use keep, change here and turn this all into sums. And then I need to check and see, is this the sum of a monomial? Well, remember, a monomial is the product or the multiplication of numbers and variables. So that's what I'm looking for here. So I have 6n to the power of 4. So that's really 6 times n times n times n times n. Yes, this is a monomial. But if I look at that next one there, 8 to the power of n, this is not a monomial. So because this is not a monomial, this entire thing is not a polynomial. So essentially what we're looking for is there anything in that expression that breaks the rules of monomials or doesn't consist of a sum of monomials? So then if we look at the next one here, I see 2x squared, so 2 times x times x. Yes, that's a monomial. X is just a variable, so that's a monomial. And if I use keep, change here, I have -5, and that's a monomial. So I have the sum of 3 monomials, which is in fact a polynomial. Then if I look at the third example here, what I notice is that I have a negative exponent here. And I remember when dealing with negative exponents, that's really 1 over n to the positive 2 power. And because of that, this term right here is not a monomial. It can't have division involved. So as a result, this entire thing is not a polynomial. Then if I look down at 9, 9 is a monomial. It's just a number. And as a result, this is considered a polynomial. Then if I look at the next one, I have 7 times b times c times t times c. That's a monomial. And I have 4 times b times b times b times b times c. That's a monomial. And those are being added together, so that results in a polynomial. And finally here, I see that I have 6, that is a monomial. 4x squared is a monomial, and here I can do keep, change, and 3 is a monomial. So while I have 3 monomials in here, I also notice that I'm not adding all of these monomials together. I'm actually performing division amongst these monomials. And as a result, this is not a polynomial. So again, I'm looking for things that either break the rules of monomials, or we're having monomials, but we're not summing them or adding them all together. Now, polynomials, because they consist of multiple monomials, do have a standard form they are typically written in. So we're going to practice rewriting these, as writing polynomials into standard form is generally just good practice when working with polynomials. And a polynomial is written in standard form when it has its terms in order from highest degree to lowest degree. So in order to do this, the easiest way is to first go through and utilize keep, change, change. So I'm going to go through each of these examples here, and I'm going to utilize keep, change, change. Then from here, what I'm going to do is I'm just going to rewrite the function. So in this case, it's p of x. And what I'm going to do is I'm going to look for the highest degree or the highest power term first. And what I notice in this first example is that negative 3x to the fourth has the highest power. So when written in standard form, that needs to come first because it's the highest power. So we have negative 3x to the fourth. And then I look for the next highest power, which is 3. So I have a positive 6x to the third. And then I look for the next highest power, which is 4x squared, and the smallest power, which is x to the first power, which is just 5x. So you'll see that the signs stayed with the numbers. All we did was rearrange this so that the highest degree term came first and the lowest degree term was last. Then for this next one here, we have h of x. And again, we're looking for the highest degree term, which I see here is in this negative x to the fifth. And remember, a negative in front of a number is a negative 1. Then I see my next highest power is that negative 6x cubed. My next highest power is 5x squared. And my next highest power is 3x. So just like a monomial has a degree, a polynomial also has a degree. And the degree of a polynomial is the highest degree of all of its terms. So you'll see below that we have two different polynomials. And within these polynomials, if we want to find the degree, all we have to do is look for the highest degree term, which if I look here, the degree of this first term is 1, this one is 6, this one is 4, and this one is 0, because I'm looking at the exponents of the variables. This is my highest degree term, and because the exponent is 6, this is a 6th degree polynomial. If I then look at the second example, I can see that I have 4 as the degree for this first term, 3, 5, and 1. So again, I'm looking at the exponents of the variables, and what I notice here is that this 5 is the largest one, so this is a 5th degree polynomial. Now, the leading coefficient of a polynomial is the coefficient of the first term, or the number in front of the first term, when a polynomial is written in standard form. So what we're going to need to do here is we're going to need to rewrite these polynomials into standard form and then determine what the leading coefficient is. So remember, standard form is when we write them in order from highest degree to lowest degree. So if I start with this first one here, I notice my highest degree term is 7. So I'm going to start with 4x to the 7th. My next highest degree term is minus 2x to the power of 1. And then my constant of 3 comes last. So for this one, the leading coefficient is the number in front of the first term when written in standard form. So my leading coefficient here is going to be 4. If I then look at my next example, I see that I'm going to use keep, change, change in here to prevent an error. But what I notice here is that this negative 1x to the power of 9 is my highest degree. Now you need to be very careful that you don't lose that negative that was in front of that x, because that actually is related to your leading coefficient. So I found my first term in my standard form. My second term is negative 2x to the 6th, and my third term is 14x. So then once I have it written in standard form, this leading coefficient here is the number in front of the first term, which is a negative 1. And finally here, we have types of polynomials. So we've talked about degree of polynomials, the leading coefficient of polynomials, and then we can also classify polynomials based on their number of terms. So if a polynomial has one term, it's called a monomial. If a polynomial has two terms, it's called a binomial. So think of bicycle, that bi makes it 2. 3 terms is called a trinomial. So think of a tricycle. The tri means 3. And then any polynomial with more than 3 terms is just going to be called a polynomial, meaning many. So now let's put this into practice. And if you aren't sure what it means by based on number of terms, remember your terms are your number of monomials being added together. So if I look at this first one here, what I notice is that I have 1, 2, 3 monomials being added together. Because there are 3 terms here, this is going to be called a trinomial. Then if I look at this next one, I notice there's 1, 2. Because there's 2 terms, this is called a binomial. Then I have 1, 2, 3 again. I notice that's called a trinomial. 1, 2, 3, that's also called a trinomial. Remember, if there were more than 3, it would just be called a polynomial. Then this one has 1, so since it has 1 term, it's called a monomial.